The geology that surrounds the epicenter or make up the epicenter of the magnitude 5.6 earthquake in 2023 gives insight as it relates to why there would have been noted or observed so many landslides, to say the least. Now, this insight is important for you so that you can be able to understand what are the likely outcomes specific to the geology that your property may be located on. So, with this being highlighted, here it is now that I present to you a couple of things that you should take note of. On top is a cross-section that highlights the general geology from an east to west, or rather from a horizontal makeup of the landscape. There is a north arrow, and generally speaking, the geology is as follows. White limestone, there is yellow limestone, there is purple, or rather there is igneous rocks, and of the igneous rocks, there are the purple, blue, purple, creamish white, to name a few. Now, this highlight, I am making mention of same from right to left on this map. Now, with this being indicated, the white limestone, in terms of what it is that I can observe or would have observed, is that there would have been landslides present. Now, if you look at also the nature of this specimen, you can see holes, and that is an indicator of the potential of, let's just say, sinkholes. So a hazard potential would be subsidence in the event of a relatively strong enough earthquake. Then we talk about the yellow limestone group. The yellow limestone, based on the nature and what it is I've observed, showcase that it is susceptible for landslides. The sandstone would have revealed that there also exists some degree of landslides or land slippage as well. The nature of the sandstone is such where it is laminated. So you can think about it being in such a way where, yes, it's easy for slippage to take place. In terms of the purple volcanics, you can take away from it that it is susceptible to landslides as well. And part of it has to do with the reality that there exists certain clays that would make it easy for slippage to take place along certain plains. And similar is said for the creamish volcanics. As a matter of fact, you can see in a clip that the purple and the creamish volcanics have somewhat of an intermixing. Now, as it relates to the landscape, what it is I can say is that I would have observed a splitting in a specific location. And this splitting I interpreted as a fault scarp. And with this being highlighted, it is giving indication, or is an indicator that obviously, yes, this landscape in of itself has exposure to the overall faults and earthquakes that have near surface rupture. Now, in addition to cues that highlight sun slippage, what I also would have observed are those signs of slow movement of the landscape. And this image reveals that infrastructure, man-made infrastructure, let's just say it's a drainage, that showcase a degree of tilting. And this tilting, I attribute it to slow creep. And the slow creep, in other words, is as a result of the slow movement of the landscape. And this is partially in respect to the earth movement in my estimation. Now, at this time, what I bring to your attention is the granodiorite. I observed granodiorite at sections of Swift River. Now, when I was mapping the entire location that surrounds or takes me towards the epicenter of the magnitude 5.6 earthquake, the granodiorite would have also been found at the specific point whereby I would have observed or deduced that this is the actual location of the magnitude 5.6 earthquake. Now, looking at this cross-section here, what it is that you can take away from the geology is we have the volcanics, and then we have the purple highlighted as granodiorite. Specifically focusing on the purple, you should see the dashed lines, and the dashed lines represent the inferred fault that I would have observed. Now, this fault, as how I plotted on this cross section, has a trend of southwest to northeast, or south southwest, north northeast. In terms of its approach, based on how I have it plotted, is that it basically is coming from deep depths and it breaches the surface. Now I'm going to highlight a video, and this video will let you see what it is that I am saying here as it relates to the landscape that is immediate within the magnitude 5.6 epicenter. Look like I can't go across this one though. This one here. What's up all the way down this way down. So this is officially where Shirley Castle to Claverty mapping comes to an end. So as you can see, ladies and gentlemen, the geology has a lot to do as it regards to how you should move forward with putting in the necessary engineering measures to mitigate against the forces that can come with an earthquake. That's one. Two, knowing the nature of the landscape as it regards to active faults and where these active faults are, as well as the history of their seismicity, is also significant towards the engineering structure or retrofit, if you will, of your property of interest. So hopefully you can be able now to take this insight and apply it to your overall reality. And hopefully it can go a far way towards helping to keep you safe in our ever-changing geo environment.